Hey everyone, today we are solving the Koko eating banana problem. But instead of jumping straight into the code, I will walk you through the intuition first, how to think about this problem, then why binary search is perfect here, and finally the implementation. Let's get started. Here is the problem that Koko is a monkey who loves to eat bananas, and we have given a array of piles, and every pile have number of bananas like the zeroth index representing there are three bananas, so there is one pile and it have three banana. Coco want to eat all the bananas within hr, that h is total number of r which she have to eat all of the bananas. So we have three different conditions here. First condition is that Coco eat at constant speed of k. There is a constant speed we have to find out on which Coco can eat. Second condition is that if she finish a pile, if she finish a pile, she move to the next one. The third condition is that she can only eat one from a pile at a time. She can eat only one pile at a time. So we have three different conditions here. We have to follow these conditions and solve this problem. So our goal is to find the minimum speed, the minimum speed k that allow her to finish all the bananas within hours. Within these number of hours, we have to finish with the minimum speed. So how do we approach this? Let's build our intuition first. So we have given a pile of array 3, 6, 7, 11, and h is 8. H is the number of hour in which we have to eat all of them. So what will the first observation of this? What if Coco eat very slowly? Very slowly, like we can say one banana per hour. If she eat one banana per hour, then within 8 hours she can eat only 8 bananas. But we have to finish all of them. Like if we do a summation of this, so 3 plus 6 plus 7 plus 11, almost we have to finish 27 bananas within 8 hours. But if we go one banana per hour, so we cannot finish this task within 8 hours. What if Coco eat very super fast? Like she can eat 100 banana per hour. 100 banana per hour. So we can finish this task within time limit in just in 1 hour. We have 8 hours, but we can finish this task in only in 1 hour. But here the key insight is that if Coco can finish at speed k, she can definitely finish at any speed which is greater than k. If Coco can finish this banana at a speed k, suppose we have a speed of 100 right now, like we can eat 100 banana per hour. So Coco can finish these banana in 101 hour as well, 101 speed of 101 and 102 as well. So what I want to say, if she can eat at the speed of k, she can finish this task within the speed of k plus 1, k plus 2, k plus 3 and so on. Okay, so if the speed 5 work for us, suppose if the speed, if we can say that constant speed is 5, if that 5 is speed, that speed is work for us, then 6 will be work, 7 will work, 8 also work, these all number will work for us too. This mean the answer will look like, 1 2 3. Suppose these speed are not working, like if she is eat one banana per hour, two banana per hour, three banana per hour, we cannot finish task within 8 hours. But if she can achieve this with the banana per hour, then she can also finish this in the 6, in the 7 as well, and in the 8 as well. Okay, you notice something, we have there is a clear boundary. Everything below a certain speed fails. Like if the fourth one is the minimum, then below 4 yani means 1 2 3, for all these value below this 4, all these value the Coco will fail to achieve his task. But above the 4 she can eat at any number. Like if she eat 4 banana per hour, she can achieve the task. With the 5, she will achieve. With the 6 as well, with 7 as well, with the 8 as well. So this is a classic search problem. We have to find out total number of hours within the range. That range will come from the how we will find the range. We will find the range. We will find the range by using two pointer. How we'll find the range with the two pointer? We can find the left, that will be the minimum boundation, and the right will be the maximum. Right will be the maximum. But if we want to solve it without the binary search, then we can go through like a linear search for it. We can do a linear search as well, right? We can do a linear search. Also go with the linear search as well. Now you like if we have, let's say the maximum pile has 1 billion banana. Maximum pile has 1 billion of bananas. If we check every speed linearly, okay, we can with the linear search we have to try like linearly we are searching. We have to try with 1, we have to try with 2, we have to try with 3 and 4, 5, 10 and so on. So we might need to check millions of billions of speed. That will be create a time complexity of big O of m into n, where m is the maximum pile, m representing the maximum pile, and n is representing the number of piles. So it will create a time complexity of big O of m into n. But remember our inside, the speed pace is sorted. The speed pace is sorted. So we can go with the binary search. Like the minimum speed is representing our left and the maximum speed, which can be like 100 or 200, whatever we can. So it will represent our right. So that is the sorted one. So we can go with binary search. So binary search will reduce our time complexity from big O of m into n to big O of n log n. Okay. So instead of checking 1 million speed, we have to almost check around 20 speeds only. In these 20 speeds, we will can find out the minimum speed which we needed. Each iteration cut the search space in half. Like suppose we are searching from 1 to 100 and we find out with the binary search that mid is 50, and we check out that 50 bananas with the 50 bananas per hour we can achieve this task. So we do not need to find between 50 to 100. We will the next iteration will find from 1 to 50 for the minimum speed. So binary search will cut this speed into half in every search. So okay, so how does the binary search work in this specific problem? Define our search space. The first thing we have to do, we have to define our search space. What will be the left boundary and what will be the right boundary? As I told you, we have to go with the two pointer like we do in the binary search. We find out mid from the left and right. So we have to find out first the left boundary. That will be the minimum possible speed. That is 1. The minimum possible speed will be 1. And what will be the right boundary? The maximum pile size. We will pick the right boundary will be the max pile size. Max pile size. Eating faster than this is pointless because the maximum pile size is suppose 10. So we can eat 10 banana at a time. In the previous array which was given to us, there was maximum pile size will be 3, 6, 7 and 11. The maximum pile size is 11. If I eat 11 bananas per hour, then almost this task will take 3 hours only to finish. Because if I eat 11 banana per hour, then in the first hour I will eat 9, in the second I will eat 7, and the third one in the 11 I will eat all the bananas. So going beyond this 11, there is the point will be the search will be the pointless. Okay, The step 2 binary search loop. The loop will run as usual. Left is less than right. And we will find out the mid. How we find the mid? We will find the mid from math.floor. Left plus right divided by 2. That will be give the mid. So if our left is on the first and right is on 11, then the mid will be 1 plus 11, that is 12 divided by 2, that it will be 6. So first we will check that if the speed will be 6 banana per hour, then we can finish this task or not. If we can, then this is the solution, or we can go beyond this, like we can search between 1 to 6. Then again, in the first search, what we will do, we will search between 1 to 11 with the mid of 6. Then if in the 6 we can do this task, then above 6 there is no need to search again. We can, then next search will be like 1 to 6. Then we will find again one mid again. Then we will search if 3 is in the 3 banana per hour, this is possible or not. If it is possible, then we will go with 1 to 3. If it is not, then we will go 3 to 6. Okay. Now let's come to the very short dry run. Let's show you this with a concrete example. Suppose we are taking the same example 3, 6, 7 and 11 with h equal to 8. Now left is 1 and right is 11, that is a maximum pi, and mid will be 6. Mid will be 6. Then I will check if she eat 6 banana per hour, then in this array she can eat the first pile in first hour, the first pile. In the second hour she can eat again this pile, all 6 banana. In the third hour she will eat only 6 and 1 will be the left. Okay, it means she need almost 2 hours for this. So, and the next 5th hour, 5th and 6th hour, she will eat this 11 banana of pile. So she need 1 hour for this, she need 1 hour for this, she need 2 hour for this, and she need 2 hour for this. So almost she will take 6 hour to complete eating, and which is less than equal to 8 hour. So that means she can eat with the speed of 6 hour per banana. Okay, so that means we can go slower, we can check for this. So next that 1 will represent our left and 6 will represent our right. Now we have to find out the mid again, that will be 3, or mid will be 3. Now we will test the same array again with the speed of 3. So if I test the same array with the speed of 3, then she need 1 hour to finish the first pile. Then she need 2 hours to finish the second one. Then again she need 3 hours to finish the 7th one, and she need almost 4 hours. She need 4 hours to finish the last one. So with this sum, we have to, like, we need 10 hours total, which is greater than 8. So we cannot go with the 3. So the next range will be from 4 to 6. Our left will represent mid plus 1 and right will represent the previous 6. Now we will find the solution from 4 to 6. The left is on 4, right is on 6. The mid will be around 5. So we can search for 5. if we go with the speed of 5, then for the array 3, 6, 7, 11, we can finish like 1 hour for this one, 2 hour for this one, then again 2 hour for the 7, and we need 3 hour for this. So almost we took 3 to 5 and 8 hour. We need exactly 8 hour. Okay, we need exactly 8 hour if the speed of 5. Then we will again search for 4 to 5. Then we will search for left will be the 4 and right will be the 5, and mid will on the 4 again. The speed, now we are searching for the speed 4. If she eat 4 banana per hour, then what will be the, like, how many hours we will take if she eat 4 banana per hour. So for 3 banana she will take 1 hour. For 2 banana she will for 6 banana she will take 2 hour. For the third index, like she have 7 banana, she will take 2 hour, and for the last 11 bananas she will take 3 hour. She will take total again 8 hour. So means this task can achieve with the minimum speed of eating 4 bananas per hour. So that is the understanding that how we can achieve this task. We have to find the left, that will be the minimum speed, and right will be the maximum speed of pile. So now we understand the logic. Let's look at the code. First, our helper function to calculate r at a given speed. Like we need a helper function in which we will pass the speed, and that helper function will return how many r we needed with that speed. So I will write a helper function that will be calculate r, in which I will pass the speed which I selected as a mid, and it will return how many hours I needed with that speed. So let's suppose that that r is equal to 0, and for let pile of, and in this I will calculate r plus equal to math dot ceil pile divided by k. Pile divided by k. It will return, and I will return the total number of hours. I will return the total number of hours which I needed with that speed. This helper function will help me to find the total number of uh, r I needed with that speed. Suppose I've sanded k as 5. K is representing that mid which we picked from left and right. Okay, which we picked from left and right. With that speed, how many hours I needed? Like we have find out with the 5 speed we need 8 hours, and with the 4 speed we also need 8 hours. So this function will return the speed, that how many hours I needed with that speed. Then I need to declare my left and right. That will be 1, and right will be the, what will be the right? Right will be the maximum from the pile. Math dot max from the pile. Whatever is the maximum value. Okay. And with the binary search, what I have to do? I will write left should be less than right, and const mid equal to mat.floor, which will calculate the mid of this, left plus right divided by 2. Okay, if that mid is that mid is less than equal to h, not mid, whatever the number of r this helper function will return is less than equal to h, then what we will do, we will shift right, otherwise we will shift left. Then we will do calculate r, and we will pass mid as a parameter, less than equal to h. Whatever the r this helper function will return, we will pass it as a parameter. Sorry, we will pass the parameter mid as a parameter, and we will compare with the edge whatever r's this helper function will return. Then we will update left and right accordingly. So right will be the mid if that speed is in, if that with that speed we can achieve the task, then right will be move. If we cannot, then we need to increase the speed, then we will increase left equal to mid plus 1. Okay, after all of this we will just return the left. So it will give the minimum number of hours in which the Koko can eat all the bananas from the piles. So hopefully you can understand this solution. So we can submit this question on the Leetcode as well. Let's go to the Leetcode and search for the same question. We will submit this one. The problem statement is 875, that Koko. Okay, I'm writing the solution in JavaScript. So what we have to do, first of all, we have to find the left boundary and the right boundary. So I will write let left equal to 1 and let right equal to, what will the right? Right will be math dot max, m will be the capital, math dot max dot pi. Okay, that will, it will give the maximum from the pile. In the example we have seen that 11 is the maximum, so it will give the 11, and left boundary is from the 1. And then we will write like left is less than right, and then we will calculate the mid is equal to math dot floor left plus right divide by 2. Then we will check this mid, that we can achieve this task with this number of hours or not. So we will write a helper function. I'm using the closer because I'm using JavaScript here. You can, if you are working with different language, you can work accordingly. So that will be the k, and I will write this function let r equal to 0, and for let pile of piles, if then r plus equal to math dot ceil is pile divided by k, and after that I will just return the total number of r I needed with that speed r. Okay, then I will check if that calculate speed whatever that function will return. I will check that if that is less than and equal to h, less than and equal to h, but we have with this we have to pass the mid as a parameter. I pass it, and after with this, like if that task is achievable with that mid, we will update right, otherwise we will update left, because if with that speed we cannot achieve this task, then we have to increase the speed. Then what we will do, we will update our left with mid plus 1, because we already tested the mid. After that I will return the left which have the actual number of the minimum speed which is containing, and I will run this solution, we have passed all the 3 test cases, and I will submit it. So we have submitted successfully. If you like the solution, if you like the video, do not forget to like this video and subscribe us as well for the more videos in the future. For now, tata bye bye.